pH affects how the protein unfolds, affects its stability, all of that jazz. Okay? So, acid base. So we can write a generic equation for an acid dissociating in solution or in water, let's say. So HA is our acid, and it can go to a proton plus the conjugate base. So HA is, this is our generic equation for an acid. This is our proton, and this is our conjugate base. Okay? The acid is also a proton donor. The conjugate base is a proton acceptor. You may be familiar with like Lewis bases and electron parts. We're not talking about any of that. This is the only version we're looking at. Okay? So the definition of an acid is a molecule that dissociates in water to give up a proton. And a base, then, our conjugate base, is an acid with its hydrogen removed. Our simplified definitions. So if I want to write an equilibrium constant for the forward reaction, K, what goes on the top? Concentration of my products, okay? So the concentration of the protons, the concentration of the conjugate bases over the concentration of my acid, okay? This would be just the basic definition of equilibrium constant for this forward reaction. For this acid-base reaction, we're going to give this subscript little a, and we're going to call this the acid dissociation constant. And what K sub A tells us, what this acid dissociation constant tells us, is the extent to which our acid dissociates in water, and it lets us distinguish between strong and weak acids. So if K sub A is a very high number, okay, and the acid has dissociated nearly completely into protons in conjugate base, we say that this is a strong acid, such as hydrochloric acid or HCl. It has an acid dissociation constant of approximately 1,000, and so we think of this as complete dissociation or nearly complete dissociation. If our acid dissociation constant is a really low number or a small number, then it's a weak acid, such as acetic acid or CH3, COOH, acetic acid. What does acetic acid smell like? Vinegar, correct. I used to electrospin my nanofibers for grad school out of an acetic acid solution, so I didn't mind it, but it was potent in this tiny little room. Okay. So the acid dissociation constant for acetic acid is about 1.8 times 10 to the negative fifth. Okay. So dissociation is sort of very little. We have mostly reactants. Okay. The acid sort of stays as an acid. So one of the things I can do now is take the log of both sides of this equilibrium that I've set up, this acid dissociation constant. So if I take the log of, in base 10 now, we're not doing natural logarithm anymore, I would have the log base 10 of K sub A is equal to log base 10 of the protein concentration. So all I've done here is pulled this out as multiplication. And when I'm taking the natural, or any logarithm, okay, by properties of logs, any logarithm of something, the product of two things, I can add them together, okay? So this is then plus the log base 10 of the concentration of the conjugate base over the concentration of the acid. And then if I rearrange these, I can write this as negative log base 10 of my proton concentration is equal to negative log base 10 of my acid dissociation constant plus the log base 10 of concentration of the conjugate base over concentration of the acid. Okay. What is this piece here called? What is the negative log base 10 of the proton concentration? This is pH. What's this called? pKa. There's no special name for this part. If you want to, this is just, if you would like to memorize this so that you can maybe always remember it for me, that little lowercase p in front of pKa or pH for me, I just immediately tell myself this is a negative logarithm base 10. Take the negative log base 10 of that thing, the end. Like, then I don't have to have that equation memorized. Yes, it's on your equation sheet, but I just know what to do. Take the negative log. There it is. And so this equation here, pH equal to pKa plus the log base 10 of the concentration of conjugate base over concentration of the acid is called the Henderson-Hasselbach equation, or HH is probably how I'll shorten it going forward. If the concentration of the conjugate base is approximately equal to the concentration of acid, this term is approximately 1. That means this would go to 0, and pH would be equal to pKa. And I set this up when I want to set up a buffer.